In this lesson, we're going to talk about equivalent fractions and prime factorization, but the end goal of this video is to be able to compare fractions. Now, we're pretty much going to do every step that's involved in adding and subtracting fractions. We're just not going to actually add or subtract them. So anyways, if you struggle with addition, with fraction addition and subtraction, this video is still going to be very helpful, but if you cringe a little bit when you hear the word fraction, right? That's okay, I get it. I'm gonna try to help you understand what fractions are. I like to think of it in terms of pizza slices. So that's what this first box is about. Now, I recommend that you pause this video and you answer these questions on your own. I linked the PDF below, so you can even print out your own PDF, or if you have an iPad, you can put it on your iPad or whatever tablet, but I'm going to go over it, but you should pause this and try this. The first one says, suppose a pizza was cut into 2 slices and you ate 1. Shade the pizza accordingly. So the pizza was cut into 2 slices. So we're going to cut it in half right here into 2 slices. And then we'll pretend like that's a perfect half. And you ate 1 of them. So we're going to shade in 1 of these right here. And then below it says, state how much pizza you ate as a fraction. Well, it was cut into 2 slices and you ate 1 of them. So the fraction here is going to be 1/2. Now, if you didn't try that one on your own, again, I would encourage you to try these other 2 on your own. But I'm going to do them right now. Here we go. Suppose a pizza was cut into 4 slices and you ate 2. Shade the pizza accordingly. So this time we're cutting the pizza into 4 slices. And then you're going to eat 2 of them. So 1, 2. And then down here below, state how much pizza you ate as a fraction. There were 4 slices and you ate 2 of them. So 2 out of 4. 2 out of 4 would be the answer there. And then lastly, suppose a pizza was cut into 8 slices and you ate 4 of them. So we're going to cut this into 8 slices. If you just keep cutting in half, you'll eventually get there. Here we go, 1 more. Obviously, I'm at an advantage with the iPad, but here we go. Shade in 4. You eat 4 of these. And then state how much pizza you ate as a fraction. Well, there were 8 slices and you ate 4 of them. So, good. You may already be seeing what I'm getting to here. But what is this? This asks right here at the bottom, state any observations you made or any patterns that you notice from these 3 examples. So again, you probably know what I'm about to say. And the point here is that all 3 of these fractions, all 3 of these situations are the same. In each situation, you ate half of the pizza. Now, it was split into different sizes, but you still ate the same amount proportionally. And so yes, what is the point here? The point here is that 1/2 equals 2/4, which is also the same as 4/8. Sorry, that's an ugly 4 right there. Let's fix that 4, right? These are all equivalent fractions. So just again, I'm making the same point over and over and over again. But if one person said, hey, I had this pizza that was cut into 8 slices and I ate 4 of them, and you had this other guy that said, well, my pizza was cut into 4 slices and I ate 2 of them, well, who ate more pizza? Well, assuming that the pizzas were the same sizes, neither. They ate the same amount, right? It is proportionally the same. These are equivalent fractions. So here we go. Here's the actual math. We want to fill in the missing numerator or denominator so that the following fractions are equivalent or equals. Here's how you do this. Well, again, I recommend you pause the video, pause this, and try as many of these as you can. But I am going to do them. Here we go. Here's how you figure this out. One way you can figure this out is I'm looking, the 3 turned into a 6. How did the 3 turn into a 6? Well, you would have to multiply by 2. Now, whatever happened on the bottom, you must also do to the top. So I'm also going to multiply the top 2 by 2, which gives us an answer of 4. So 2/3 and 4/6 are the same fraction, the same value, just out of a different amount of slices, if you will. Answer there is 4. Next one, same thing. How did this 4 become a 12? How did this 4 become a 12? Well, you'd multiply by 3. You would multiply it by 3. And the same would be true. You got it. Well, you have to do this to the top. Whatever happened to the bottom, you have to do the top. And 5 times 3, what's 5 times 3? 5 times 3, that's 15. So the point here is that 5 out of 4 is the same thing as 15 out of 12. Those are the same proportion, the same fraction. Good. Here we go. Here, the numerator is given to you, but the process is still the same. What do I need to multiply 3 by to make it an 18? And that is going to be 6. Do the same thing to the 5 below. 5 times 6 is 30. 5 times 6 is 30. So 3/5, 3 out of 5, is the same thing as 18 out of 30. Those are the same fraction. They have the same value. Good. Here we go. This one you multiply by 7, so it's going to be 77. I'm going to speed things up a little bit here. 77. How about this one right here? This one right here. The denominator got multiplied by 4. So, this one's a little bit backwards. Maybe we want to go backwards on this one and think backwards. So, how does 48 become a 12? Well, since 12 is smaller, instead of multiplying, let's do this in terms of division, right? Divided by 4. What about 36? What is 36 divided by 4? And 36 divided by 4 is 9. You basically just reduce the fraction. That's what just happened here. Same thing. Good. How did the 8 become a 64? How did the 8 become a 64? Well, that's times 8. Do the same thing to the 9. We're going to multiply that by 8, and 9 times 8 is 72. The answer there is 72. Here. All right, here it's by 5, so this is going to be 40. It's going to be 40. And here this is by 9, so that's going to be 12. That's going to be 12. You might have to think about that, but the answer is 12. The answer is 12. There you go. There's all the answers right there. Do you want to check your answers? All right, good. Equivalent fractions. Now, we're going to step away from equivalent fractions here for a minute. We're going to seemingly do a different topic, but it'll all come together in the end, right? The very end here is we're going to compare fractions. That's our end goal. But first, let's talk about prime factorization, because this is going to be useful to us when comparing fractions. How do you find the prime factorization of a number? So we'll start with this 12 here. And 12, well, I could split that up into a 2 and a 6. You could also do 3 and 4. That's fine, but either way will work. 6 breaks apart into 2 and 3, and I'm going to keep track of my prime factors here. So the first branch ended at a 2, this branch ends at a 2 and a 3. Now, because there are 2 2's, right? We have 2 2's here. Oh, I want my highlighter. Because there are 2 2's, we're going to write in our answer 2 squared times, and then we have 1 3. So 2 squared times 3. That is the prime factorization of 12. So, good. Pause and try these. You have smaller numbers on the top row, and the numbers get a little bit bigger on the second row. So see if there's any of these you can figure out. I will quickly go through them. 18, you could break that up into a 6 and a 3. 3 is prime. So we're going to save that for the answer. 6, however, breaks apart into a 2 and a 3. So we have a 2. So we're going to use a 2. And then we have 2 3's. So we have 3 squared. And that right there is the prime factorization of 18. Moving on to 20. 20, you could break apart 20 into a 2 and a 10. You could break it apart into a 4 and a 5. Right? There's no way you have to do it. You could do it either way you want. In fact, you should do it both ways, and you should get the same thing. So here, I also broke apart the 4 into 2 2's, which gives us a final answer of 2 squared times 5. And that right there is the prime factorization of 20. 28. Break that apart into a 4 and a 7. 7 is prime. 4 breaks into 2 and 2, which are both prime. So your answer here is 2 squared times 7. 2 squared times 7. On to the second row, we have a 45. 45, I would split that into a 9 and a 5. You could also do 15 and 3. Either will work. 5 is prime. However, 9 can be broken down into 3 times 3. So the prime factorization of 45 is 3 squared times 5. Here comes 63. 63. You could break that apart into a 7 times 9. Let's have a little fun. You could break this apart into a 3 and a 21. That also is true. 3 is prime, so we're going to underline that. And then 21 breaks apart into, that's 3 times 7. So we have 2 3s and a 7 for an answer of 3 squared times 7. And that is the prime factorization of 63. About 110. 110, right? A little bit bigger, but here's a trick. If a number ends in 0, it is divisible by 10. So you could always do that. We could do 11 and 10. Well, 11 is a prime number, so we're done there. 10 breaks apart into a 2 and a 5. This is the first example where we haven't had any repeated numbers. There's 1 2, there's 1 5, and there's 1 11, and that's okay. That'll happen. So the prime factorization here is just 2 times 5 times 11. 120, it ends in a 0, so let's use that. That means we could break this apart into a 12 and a 10. Now, neither 12 nor 10 are prime, so both of these we can keep going. 12, we could do a 6 and a 2. 10, we could do a 5 and a 2. So let's pause. Let's look at this row. 6 is not prime, but 2, 5, and 2 are. So we just got to keep going with the 6 here. Break that apart into a 2 and a 3. We got a lot here. So notice how this time we have 3 2's. That means our prime factorization, we will have 2 to the 3rd power because there's 3 2's. There's 1 3 and there's 1 5. So the prime factorization here is 2 cubed times 3 times 5. Good. There's one more row here. If you're feeling ambitious, if you're feeling confident, if you want a challenge, go ahead, pause the video and see if you could find the prime factorization of these numbers. 150 ends in a 0, so I'm going to go with 15 and 10. The 15 can be broken down into a 3 and a 5, and the 10 can be broken down into a 2 and a 5. So here are the prime numbers. We have a 2, we have a 3, and we have 2 5s, so 5 squared. 165. 165, well, it ends in a 5, so it's guaranteed to be divisible by 5. Now, actually, what is 165 divided by 5? That is a good question. It is going to be, I want to say 33. I don't have my calculator on me, but let's see here. Let's double check this. 3 times 5, carry the 1, 15, 165. Yeah, we're good. All right. Now, 5 is a prime number, but 33, we can keep going with 33. 33, 3 times 11. So here we just have one of each. We have a 3, we have a 5, and we have an 11. So that's the prime factorization of 165. 165. About 504, 504. Here's a little trick. Yes, 504 is an even number, so you could divide it by 2, but let's do something else. 504, if we add up these integers, for example, if we do 5 plus 0 plus 4, that gives us 9. And this is a trick that works with 3s and 9s. If the sum of the digits is divisible by 9, then the number itself is also divisible by 9. So 504 is divisible by 9. Now, that doesn't tell us what 504 divided by 9 is, but at least it gets us a 9. So I don't have my calculator on me, but you know, that's not such a bad thing. Sometimes we just have to do this by hand. So 9 goes into 50 5 times, which is 45. bring down the 5 and the 4, and then 9 goes into 54 6 times. So here it's 9 and 56. So there you go. That's some old school division for you there. Still useful. All right, 9 breaks apart into 3 and 3, and 57 breaks apart. That's 7 times 8. So the 3's are prime and the 7 is prime, but let's keep breaking down the 8. The 8 breaks down into a 4 and a 2, and the 4 into 2 more 2's. So we got a lot going on here. This is a good one. We have, altogether, we have 3 2's for a 2 cubed, and we have 2 3's for a 3 squared with an additional 7. With an additional 7 right there. That is the prime factorization of 504. On to 540 here, that ends in a 0. So we could break this apart into a 54 and a 10. 54 is 9 times 6. 10 is 2 times 5. 2 and 5 are prime. We got to keep going here though. 9 is 3 times 3, and 6 is 2 times 3. So we got some 3's, another 2. All right. 2 2's, 3 3's, and a 5. That is the prime factorization. So, good. Those are the answers to the last 4. Those are the answers to the last 4 right there. So, good. Why bother finding prime factorizations? Well, prime factorizations are going to make it easier for us to find the least common multiple of numbers. And you're like, what is he talking about? Least common multiples? I thought we were going to compare fractions. We're getting there. We're getting there. We got one other thing we have to do first, and that is the least common multiple. So find the LCM of the following numbers. Use prime factorizations if needed. You're going to realize that it's not always needed, but we will come to the point where that it's useful. But let's start with 3 and 4. Let's say, how could you find the least common multiple? What's the easiest way to do this, or the least involved way? All you have to do is list out the multiples of each number until you arrive at a common multiple. And what you'll see here is that they both have 12. So 12 is the least common multiple of 3 and 4. No prime factorizations needed. Now maybe you're thinking to yourself, well, hold up. 3 times 4 is 12. So why didn't I just multiply 3 times 4? Well, check this out. It doesn't always work. Let's go over here to 6 and 10. So 6 times 10 is 60. Now 60 is a common multiple of 6 and 10, but it's not the least common multiple. So let's do the same thing here. Let's write out the multiples of 6. 6, 12, 18, 24, 30, so on and so forth. And let's get some multiples of 10. 10, 20, 30, 40. And there it is, right there. They both have a 30. So whereas 60, again, is a common multiple of 6 and 10, it's not the least common multiple. The least common multiple is 30. 30 is divisible by both 6 and 10. Good. Now let's go over here to 12 and 18. Actually, I'm going to zoom out right here, and there you go. You can see the rest of these problems. Try these on your own if you want. I am going to go through all of them. But we get to 12 and 18 here, and it's do we want to keep doing what we've been doing? Do we want to keep writing out the multiples until we get the same number? And you could with 12 and 18, but I'm going to show you how to do it with the prime factorizations. It's a little more involved, but at least you don't have to sit out and kind of blindly write out the multiples until you happen to find the answer. So this is why, so if you skip to this part of the video, I'm not going to reteach you how to find the prime factorizations of these numbers. I'm just going to pull them from the last page. So we did all this on the last page. The prime factorization of 12, that was 2 squared times 3. And the prime factorization of 18 was 2 times 3 squared. So here's how you can find the least common multiple using the prime factorizations. I'm going to look, and I see that we have these 2's. We have a prime factor of 2. I'm going to use the one that has the highest exponents. So I'm going to write down 2 squared. And then I'm going to look at the 3's. I'm not going to use all of them. I'm only going to use the factor that has the highest exponent. And that is 3 squared. So times 3 squared. I need to evaluate this now. 2 squared is 4, 3 squared is 9, and 4 times 9 is 36. And there you go. 36 is the least common multiple of 12 and 18, meaning 36 is the smallest number that is divisible by both 12 and 18. Good. 20 and 45. The prime factorization of 20 is 2 squared times 5. We worked this out on the last page. The prime factorization of 45 is 3 squared times 5. To find the least common multiple, we're going to go factor by factor. Now, there's only one prime factor of 2 to choose from, so we're going to use it. We don't have to pick the highest exponent because there's only one available option, and that's the 2 squared. The same thing with the 3. There's only one available option. Use it. Use the 3 squared. And then, all right, we have 2 5s, but what you notice is they both have a power of 1, technically, so that's all we're going to use. We're not going to put down 5 squared. Be careful. I get it. There's 2 5s. You may be tempted to put 5 squared, but no, you're only using the one that has the highest exponent, and they all have an exponent of 1. So that's all we're going to use. All right, now we need to evaluate this. We evaluate this. 2 squared is 4. 3 squared is 9 times 5. 4 times 9 is 36 times 5 is 180. So the least common multiple of 12 and 45 is 180. Now we're down to 28 and 36. The prime factorization of 28 is 2 squared times 7. The prime factorization of 63 is 3 squared times 7. This is very similar to the last problem. We just have a 7 instead of a 5. So, all right, we've only got 1 2 to choose from, so we're going to use it. We've only got 1 3 to choose from. We need to use it. We technically have 2 7s to choose from, but they both have a power of 1, so that's all we're going to use, right? The 7s all have a power of 1, so that's all we need. 2 squared is 4, 3 squared is 9 times 7, and this is going to be 36 times 7. All right, I'm without my calculator. Let's do it by hand. 36 times 7. Well, 6 times 7 is 42. Carry the 4. 7 times 3 is 21. Plus 4 is 25. So this is 252. 252. So 252 is the least common multiple of 28 and 63. $110 and $165. All right. The prime factorization of 110 was 2 times 5 times 11. And the prime factorization of 165, I do not remember. Let's go back and look. What do we get for 165? We got 3 times 5 times 11. 3 times 5 times 11. Okay. Well, let's see. We only have 1 2 to choose from, and it has an exponent of 1. So we copy that down. We only have 1 3 to choose from, which also just has an exponent of 1. We have these 2 5s, but they both have an exponent of 1. So that's all we can use. That's all we need. And the same is true of the 11s. These are just 11 to the first power. So there's nothing squared here. No exponents. All right. Let's be strategic here. How do I want to do this? Let's go, I don't think there is a best way to do this. Let's just do 2 times 3, which is 6, times 5 times 11 is 55. 55. All right, we got to do 55 times 6. 55 times 6. Well, 5 times 6 is 30. Carry the 3. 5 times 6 is 30 again, plus the carried 3 for 330. Okay, that wasn't so bad. 330. So the least common multiple of 110 and 165 is 330. About 120 and 150. 120 and 150. Let's see. The prime factorization, I need to grab these. The prime factorization of 120 was 2 cubed times 3 times 5. 2 cubed times 3 times 5. And the prime factorization of 150 was 2, 3, and 5 squared. 2, 3, and 5 squared. All right, least common multiple. Here we go. We have two options for 2. The one with the greatest exponent is 2 cubed. That's what we need. 2 cubed times. We do have 2 3s, but they both only have a power of 1, so we only need 1. And then we have 2 options for 5. The one with the largest exponent is 5 squared. We're going to use 5 squared. All right, 2 to the third power, 2 cubed, that is 8 times 3 times, and 5 squared is 25. Okay, good. You do not have to multiply these 3 numbers in this order. Multiplication is, I believe the word is commutative, which means you could move them around. We can actually multiply the 8 by the 25 first. Why would I want to do this? Well, 8 times 25 is not as hard as you think. Think quarters, like quarters are 25 cents. If you had 8 quarters, you would have $2 or 200 cents. And 200 times 3, well, 2 times 3 is 6, so 200 times 3 is 600. And that is the least common multiple here, 600. And lastly, 504 and 540. So let's go grab these prime factorizations. 2 cubed, 3 squared, and 7. So for 504, we have 2 cubed, 3 squared, and 7. And then for 540, oh, that's terrible penmanship. Here we go. 540. For 540, you have 2 squared, 3 cubed, times, I believe it was a 5. Yes. Okay. Here we go. This is a good example. LCM. All right, we have 2 2's to choose from. The one with the greatest exponent is 2 cubed. We have 2 3's to choose from, and the one with the greatest exponent is 3 cubed, 3 to the third power. We only have 1 5, and we only have 1 7. 2 cubed is 8, 3 cubed is 27, 5 times 7 is 35. All right, so you have to do 8 times 7 by 35. Yep, I'm giving in. I am going to grab my calculator. All right, that is 7,560. So the least common multiple of 504 and 540 is 7,560. And that is how you do it using prime factorizations. All right, now for the culmination, the point of this lesson is we are going to compare fractions. We're going to compare fractions. So again, we are going to do every step required to add and subtract fractions. But we're just not going to add or subtract them. We're going to compare them. Which one is bigger, right? So here we go. Here are the instructions. Rewrite each fraction with the least common denominator, then identify which is greater. Okay, here's another phrase. Least common denominator, abbreviated LCD. The LCD is no different than the LCM. So the least common denominator is the least common multiple, which we just did, of the denominators. So here we go. What are the denominators here? The denominators here are 3 and 4. If you skip ahead to this part of the video, you may get a little lost. We figured out the least common multiple on the previous page. Now I'm just going to take those for granted, right? We already did that work. So the LCD of 3 and 4 is 12. Now we need to rewrite 2/3. We'll call this the first fraction and the second fraction. We need to rewrite 2/3 so that it's out of 12. This is what we did on the very first page. Long time ago. Feels like a distant memory. How do you write equivalent fractions? Well, the bottom here got multiplied by 4. Do the same thing to the top. 2 times 4 is 8. 8. Do the same thing to the second fraction. We have 3 out of 4, and we want to make that so it's out of 12. Well, how do I turn a 4 into a 12? You would multiply it by 3. If we do the same thing to the top, the numerator, we're going to get 9. So to make an honest comparison between 2/3 and 3/4, what we're really trying to do is compare 8/12 and 9/12. Well, now that they're out of the same denominator, you can make an honest comparison. 9 is greater than 8, meaning this fraction is greater than that fraction, and originally that 9/12 came from the 3/4. That was 3/4. So 3/4 is the answer here. 3/4 is the bigger of these two fractions because 9 is bigger than 8. So that's the process. You have to find the least common multiple of the denominators, also known as the least common denominator, re-express both fractions over that denominator, and then you can figure out which one is bigger. Then you can make an honest comparison. All right, good. Next one here. Well, I'll zoom out and you can see, let's just display these first 4 problems here. So pause the video, try these, see what you can figure out. The LCD for 6 and 10, remember it's not 60, but it's 30. Now you would still get the problem right if you use a 60, but 30 is smaller, so I think it's a little bit easier. We need to rewrite both of these fractions so that they are out of 30. Well, how do I make a 6 a 30? I multiply by 5. Do the same thing to the numerator. Multiply by 5, and you get 25. 25 out of 30. All right, do the second fraction. Second fraction is 7 out of 10. Let's re-express that out of 30. How do I make a 10 a 30? Multiply by 3. Do the same thing to the numerator, and 7 times 3 is 21. So what we're really looking at here is we're looking at 25 over 30 versus 21 over 30. And we'll see that 25 is bigger than 21. So the larger of the two fractions is the 5/6. The answer is 5/6. 5 out of 6 is more than 7 out of 10. Ah, yes. So speaking of pizza again, right? If one person said, hey, I bought a pizza, it was cut into 6 slices and I ate 5 of them. Then someone else said, I bought a pizza, let's assume that it's the same size, but it was cut into 10 pieces and I ate 7 of them. Who ate more? This time there is a winner, if you will, and that's the person that ate 5 out of 6 slices, as opposed to the person who ate 7 out of 10, right? So these are not equivalent fractions. These are not the same. One of them is bigger. Good. All right, let's try this one. The LCD of 12 and 18 was 36. And again, we figured that out on the last page. So if you need to go back and see how we did that, do so. I need to rewrite 6 out of 12 so that it's out of 36. How do I make a 12 into a 36? Multiply by 3. How do I, so I do the same thing to the top. 6 times 3 is 18. All right. Do the same thing with 9 out of 18. We need to make 9 out of 18 out of 36. 18 times 2 is 36. Do the same thing to the top. 9 times 2 is 18. Oh, look at that. 18 out of 36 and 18 out of 36. These are equal fractions. These are equal fractions, right? Equal fractions or equivalent. Equivalent fractions. So there is no winner there. Those are equivalent fractions. All right. The least common denominator for 20 and 45. What was that? That was 180. Again, we did this on the previous page. That's 180. So 3 out of 20. Let's change that to out of 180. All right. 20 times what would give you 180? It's going to be 9. And 3 times 9 is 27. How about 4 out of 45? Let's make that out of 180. 45 times 4 is 180. 4 times 4 is 16. So we're comparing these two fractions now. Which one is bigger? The one with the 27, which originated from 3 out of 20. That is 3 out of 20 is the winner here. 3 out of 20 is more than 4 out of 45. That is the bigger fraction. Here are the last four. Pause the video, try one of these. All the least common multiples were done on the previous page. I've recycled all of these numbers. Nothing new here. So for 28 and 63, the least common denominator here, what was that? I don't remember. Let's go look. 252, 252. So we need to change 5 out of 28 so that it's out of 252. Okay. All right. Yeah, you know what? Calculator is totally understandable for this part. 252 divided by 28 is 9, right? This is times 9. So we do the top as well. 5 times 9 is 45. Do the same thing to 10 out of 63. Change that so it's out of 252. All right, what about 252 divided by 63? 4. So this is going to be times 4. This will also be times 4. 10 times 4 gives us 40. All right, which is bigger, 45 or 40? 45 is bigger, meaning the answer is 5 out of 28. The answer is 5/28. 5 out of 28 is more than 10 out of 63. The least common denominator here was 330. So 31 out of 110 equals what out of 330? Here we're multiplying by 3 times 3. 31 times 3 is 93. Don't overthink that one. You could do that in your head too. 47 out of 165. Change that to 330. That's multiplied by 2 times 2 times 2 times 2. And that is going to be 94. 94. All right. Oh, look at that. Whoa, that was close. That's a good problem. One had 93, but the second one had 94. So 47 out of 165 is, just a little bit more than 31 out of 110. That's a good one. That's a good problem. The least common denominator for these two numbers, what was that? 300, 600, it was 600. So we changed 73 out of 120, so it's out of 600. Here, this is multiplication by 5, so times 5 here. All right, 73 times 5, I'm going calculator for this one. 73 times 5 is 365. How about 101 out of 150? Times 4. Times 4. 404. 404 is bigger than 365, so the answer is 101 out of 150. 101 out of 150 is the bigger fraction. Last one. The LCD here was 7560. Double check. 7560. Yep, that's good. So we'll change 14 out of 504. All right. If you're trying to figure out what times 504 is 7,560, just reverse it. What's 7,560 divided by 504? And that's 15 here. So we need to multiply by 15. Multiply by 15. What is 14 divided by 15? That is a good question. 210. I'm using my calculator. So no shame if you have to use your calculator. What about 7560 divided by 540? Well, that's going to be 14. That's kind of cool. times 14. So I need to multiply the top by 14. 15 times 14, well, is the same thing as 14 times 15, which is 210. Interesting, fascinating. So these are the same fraction. These are equivalent fractions. Equivalent fractions, they are the same. Equivalent fractions. So there you go. Good. So in order to make an honest comparison between two fractions, they need to be re-expressed over the same denominator, preferably the least common denominator. Although not required, it will produce the smallest numbers. Now, I did mention, here's the last four if you want to check those out, but I did mention that we are doing everything you need to do to add fractions. So maybe adding and subtracting fractions still scares you a little bit, or maybe you just straight up, you're not scared, you're just annoyed, right? You don't like to do it. These are the steps. If you do these things, you've done all the hard work. And I'll go ahead and show that with the first problem here. I'm back to the first problem on this last page, where why don't we just go ahead and add these? So if I wanted to add 3/4 and 2/3, if I wanted to add these fractions, I would do everything that we did, and then at the very end, I would just stick a plus sign in between them. So let's go ahead and finish that. Plus equals, and then all you have to do is add the 8 and the 9. 8 plus 9 is 17 over 12. Sometimes you might have to reduce, here you don't. So that's the only additional step to what we've already done if you had to add or subtract these fractions. So if you can do this, you're good. You've got it, right? You can handle this. Fractions no longer have to be something that scare or annoy you. Very good. Thank you for sticking around. We'll see you in the next one.